first topic for today is called rate of change, and you can see a definition right here. It is a ratio that compares the amount of change in a dependent variable to the amount of change in an independent variable. And then we can show that with this formula here too. So change in dependent over change in independent, and we get a ratio that's set up there. So we just have to remember that if we're given a table such as this, that the dependent variable will always be the variable that depends on the other variable. So if we look at this table shows the cost of mailing a 1 ounce letter in different years. It says let's find the rate of change in cost for each time interval, during which time interval did the cost increase at the greatest rate. Okay, so in order to figure that out, we need to compare the two things. We need to figure out which is the dependent, what is the independent variable. Well, as you would imagine, as time goes on, cost typically increases because the dollar value goes up. All right, or the penny value or whatever. So first thing we need to do then is identify that cost is going to be our dependent variable, and my independent variable is the time or the year, because the cost will depend on what year it is. Okay, and let's just go through here and kind of like we did with figuring out if a function, if we had a linear function, we're going to do kind of the same thing. So from 1988 to 1990, we increased by 2. From 1990 to 1991, we increased by 1. From 1991 to 2004, we increased by 13. And from 2004 to 2008, we increased by 4. Okay. Now let's go to the bottom here. From 25 cents to 25 cents, we increased by 0. From 25 to 29, we increased by 4. From 29 to 37, we increased by 8. And lastly, from 37 to 42, we increased by 5. Okay. Well, our formula says that we can take the dependent variable over the independent variable to figure out these different intervals. So between 1988 and 1990, we had 0 cent increase over 2 years. Now we can figure out the rate of change per year if we just divide these two numbers. So 0 divided by 2 gives me 0. So this is a 0 cent per year increase. All right, so not very good there. Unless, well, actually good for the customer during that because it didn't increase. But anyway, second interval then, we have a plus 4 increase, 4 cent increase over 1 year. All right, 4 divided by 1 is 4, so we have a 4 cents per year increase during that time interval. So we've got that. We'll move on to the next one. Now we have an 8 cents increase over 13 years. Okay. Now in order to do this one, we're going to have to pull out the calculator. And if you do 8 divided by 13, you get a big, long, rational number. It's 0.615 something. So I'm going to round that to 0.62 cents per year increase. So that means every year between that interval, the price went up by 0.62 cents. Okay? And then lastly, 5 over 4, or a 5 cent increase over 4 years. If we divide 5 divided by 4, we get 1.25 cents per year. And then we can look at, okay, what had the largest increase? Well, from 1990 to 1991, we had that 4 cent increase. So this is the largest increase rate-wise, okay? I'm going to end it right here, but also if you were to have a graph and you can check this out if you want to. You could figure out the rate and change this way as well, just by looking at, okay, let's take the this 0.62 cent increase per year. You would just figure out, okay, my dependent variable is here, so how far do we go up? Well, we went from that, what was it, 20, this isn't the best graph to use, 29 up to 37, so there's a difference of +8, and then you can do the same thing for years. So from 91 to 2004, and figure out, okay, 13, and then do the ratio that way. But I'll relate this to slope next, and that's all I've got for this video.